Hello and welcome to the first video of Basics of Calculus. So this video is going to be the first video of the introductory section of the course, and in this video we're going to be talking specifically about photos versus videos. We're going to use this concept as sort of an analogy for the idea of a limit, and we're going to use it to introduce the idea of a limit. So the idea of a limit is really at the core of calculus. So a limit is this thing that kind of converts math into a sort of video camera. So in math traditionally, so prior to the limit, we had photos. And introducing the limit is kind of like the video camera of math. So let's write that right here. This is a really important idea that the limit is like the video camera of math. And what do I mean by that? So if we think of a photo, if we think of snapping a picture of something, here's a nice little camera here. We'll snap a picture of something. So got some little light. So if we snap a picture of something, that's going to be an instantaneous shot of something that happened. So for example, if you snap a picture of you and your best friend hanging out, having some fun, that's going to be a picture at one moment in time. So say that's at time t equals 0. That's when that picture was taken. If we were to really relate that to the idea of math, we could say draw a graph of maybe what you and your friend are doing over time. So if we have time on this axis, maybe this is how much fun you're having. So how much fun. And this is kind of a measure of how much fun you're having. So you're immediately having lots of fun. And then maybe it starts to go down a little bit. Maybe it goes back up again, and then maybe it goes down again, and then maybe it gets a lot better later on. Let me fill in this graph really quick. So at time t equals 0 right here, we take that picture, and you and your friend are having lots of fun. So when the function of time, where how much fun you're having is a function of time, we took that picture and we paused it at t equals 0, and the function of how much fun you were having had some value. It had a single value. At this time, when we took this picture right here, we had a single value for how much fun you were having because that was at a single instant. So say that value was 5. Maybe it's a score of out of 7, something like that. Maybe the maximum score is 7 of how much fun you're having. At that time, when t equals 0, so another way to write that would be f of 0 equals 5. At that time when t equals 0, you were having an amount of fun equal to 5. So that's nice to know and all, but what if you want to know what's happening generally over time? So what if I want to know not just what happens at t equals 0, or at maybe t equals 2, or at t equals 5 or 7. I want to know what happens throughout. So I want to know what's happening throughout this entire graph. Over time, what's happening to my friends and I's happiness? Is it going up? Is it going down? Where is it going up? Where is it going down? When does it reach its highest? All of these things are things that I want to know. Highest, when is it highest? When is it lowest? When does it increase? When does it decrease? These are all things that are important. These are things that are going to help me talk about my friendship and share these ideas and these memories with other people. These are going to be the important things. So believe it or not, these are actually things that can be calculated using calculus. And that's all going to relate to the idea of a limit. As I said, the limit is the video camera of math. What that means is that it's like having a camcorder. So let's draw the camcorder right here. It's like having a camcorder to record what's going on, as opposed to just taking a still photo. So instead of having a single moment in time, I can record all of the fun that my friends and I are having. I can record maybe from time t equals 0 to time t equals 10. Can record all of that. And that way I can not just analyze that one moment, I can analyze all of those moments, and the limit is the key to this. So in reality, in math, the way the limit works is it works off the idea of an approach. So when we have a function, so again, let's refer back to our function of happiness, how happy I am. Oh, sorry, it wasn't happiness, it was how much fun. So let's erase that, how much fun my friends and I are having. I'll try to draw this graph about the same. I don't think that was exactly the same, but it's a similar idea. So we want to know how much fun my friends and I are having. This whole idea of a limit works off of an approach. So what we do here is we say, okay, let's pick a picture that we can kind of center our limit around. So in this case, it would be convenient for us to pick a picture right here in the middle. Say this is time t equals 5. So maybe in this picture we see that our how much fun we're having function has a value of, I don't know, 4.5. So f of 5. No, this is just function notation. I know I've been writing this. For those of you who don't know this is just function notation. It says that we have a function of some value t. In this case, t is equal to 5. And then the value of that function at that point is going to be 4.5 in this case. Earlier we said that it was 5. So what we're going to do here is we're going to say this is our picture that we're going to center our video around at f of 5. So then what we can do is we can actually look at the function, and based on the characteristics of the function, say that f was a quadratic function, so f of t is described by some relationship t to the 4th plus 3t to the 3rd minus 2t plus 5. So in this case, we might say that this is an example of our. This is not an accurate depiction of the function I've drawn, but say this was a function describing how much happiness we had. Then what we can do is we can use this relationship, this equation right here. And by the way, if this equation seems a little confusing, there is going to be a prerequisite / what you need to know section of this course. So if any of this notation, any of the language that I'm using, any of the math notation seems confusing, there will be a long section on that that will make sure that you get caught up before we start with the actual material. This is just to kind of give a basic understanding of where we're headed. So we use this idea, this relationship here, to kind of form the basis of a limit. And what I mean by that is that for a limit, we're going to use this to see what happens as we approach this value. And that's why I said that we center around this value. As we approach 5, so as we approach 5 on the graph, and we're going to start off approaching it from the left, because that's how we read a graph, from left to right. That's how we read words, from left to right. As we approach this value 5, we want to know what happens to the value of the function. So as I'm approaching 5, what does this graph do? Does it increase? Does it decrease? Does it go towards 5? Does it go towards another number? We don't know. And so you may be asking, well, why does this matter? Because for those of you who maybe are a little intuitive, you may have realized that as I approach 5 on this graph, especially in the neighborhood near 5, yes, the function's increasing, but it's just getting closer and closer and closer to 5. I mean, that's how functions work. To make it a little more simple with a linear function, we have a line, t, f of t, we can see at 3, and we want to see the limit as f of t, the limit as t approaches 3, as it gets closer and closer to 3, we can see that here, right, we can kind of think of it like adding together a bunch of photos to create this video. So say we're at 2, maybe at 3 it has a value of 4, At 2, it has a value of 3. So f of 2 equals 3. Or maybe f of 2.5 we'll see is equal to 3.5. Maybe f of 2.7 is equal to 3.7. F of 2.8 equal to 3.8, and so on. Getting closer and closer and closer to this value at 3, f of 3, and we know that that's equal to 4. So you'd say that the limit as t approaches 3 is going to be equal to 4. Because what we're asking is what this function does, what f of t does. So what does f of t do as t approaches 3? And we can see in this case that from f of 2 to f of 2.5 and so on, that f of t approaches the value of 4. And so, as I said, some of you may be wondering, why is this important? Why do we need this? I knew that the value at 3 was equal to 4, but that's not really what's most important here. What's most important here is that we've now created a tool that allows us to see what the function is doing around a certain point. We can see how a function behaves around a certain point. An example where this might be useful is a function that is discontinuous. Brief reminder, a discontinuous function, and we'll talk about this in more detail. A discontinuous function is a function that maybe has a hole in it, for example. So a hole means that at that point, either the function isn't defined or it's defined as something that's not on the same place as the graph. So what this notation here is, this circle means that the function is not, that at that point, at maybe, t equals 3 again, at that singular point right there, the value of the function doesn't lie on the graph, it lies up here maybe at like f of t equals 6. Lies all the way up here instead of being where it should be at 4 or, around all the other things. And that's helpful because we may just be given that f of 3 when t equals 3 is 6. I mean, that's how it's defined. We say that this dot right here represents the function value, so f of 3 equals 6. Maybe, going back to our happiness, maybe that picture I took at time t equals 0 was discontinuous. Maybe, let me fix this, there was actually a hole here and the value was higher than it should be. What that means is that, we may see this picture right here and we may see that, oh, how much fun were we having? We were having 6 fun here. So we would assume that around that area we were also having 6 fun. Maybe it decreased from there, maybe it increased from there, we don't know, but around that area we were also having 6 fun. But in reality, if we look at the limit of the graph, if we look at the limit approaching from either direction, we can see that we weren't having that much fun. That was just a random moment that didn't match up with everything else. Going back down to this graph, maybe this is a similar example. Maybe at this moment we were having an enormous amount of more fun. Maybe something really funny happened at that exact moment, and it caused us to have a lot more fun. And so what we would see there is if we took the limit as t approached 3, then we would see that in reality, based on the surroundings, the amount of fun that we should be having, kind of contextualized to the surrounding moments, would be 4. The limit would equal 4, but the function value would equal 6. Those are two different numbers. And the reason for that is that the limit is kind of combining these snapshots to make a video to see what happens as we get closer and closer to 3, not saying what happens exactly at 3. And that can tell us a lot about functions, and it can be a useful tool that can prove really helpful when talking about other things like how is a function increasing, where is it increasing, by what amount is it increasing? How is it decreasing? It can be useful for telling us about the rate of change of a function. We'll talk about that in more detail. And it can be useful for plenty of other things, like finding the highest point, the lowest point, and many other things. In fact, many unrelated things too, such as the area under the graph, or maybe the slope of the line that is tangent to that point. And we'll talk about all of this in more detail later on in the series. But the important thing to know here is that having this concept of a limit brings a sort of continuity into math that hasn't been there before. So when we've learned math before, we've learned about it in terms of pictures. So before calculus, math was pictures. Now, math is going to be videos. It's going to be pictures and videos. After calculus, we have videos. And that video, of course, is the limit. When I say that math is pictures, it's really just that we have statements. We have relationships that can be expressed as single point in time snapshots. We have one statement at one point in time. And it may not be at one point in time, maybe it's at one point in space, at one point according to some other value, but the way that we'll view it, of course, in terms of an analogy to pictures and videos, it's one statement or one picture at one point in time. And that relationship may not always be the case. So we need something to see what the general relationship is. And that's where the limit comes in, and why we need to introduce the idea of videos to math, why we need to introduce the idea of continuity. Continuity is this idea of how a function is behaving over time or across its domain in a more technical way of explaining that. Continuity is the idea behind a function that transitions smoothly from one period in time to the next. And this is kind of different from another idea of continuity that we'll talk about later in the course, but in a sense it is related. They're both related to the limit, but really here what we're just talking about is the traditional idea of continuity, the idea of being able to create one continuous sequence of events going from time t equals 0 out to time t equals any time, really, t equals infinity. A continuous series of events. To wrap it up, really what we're seeing here is that instead of a function being individual points from time t equals 0, then each point defined individually to time t equals infinity, which we couldn't even really reach because we don't know every point of the function, and this is all discrete. But it goes from that to this idea of continuity of a single function that varies continuously through time, that isn't defined by snapshots or pictures anymore. It's defined by a continuous expression over time. And the idea of how to analyze this, the first analysis tool that we have here is the limit. And like we said, the limit is really just the video camera of math. So that wraps up this video. To take away from this video, just recognize really that math has always been a series of statements about the world. That's how we've always viewed math. We've always seen it as a series of pictures of the world, where we take snapshots of relationships. Now, with the introduction of calculus, we've created this idea of a limit. The idea of a limit acts like a video recorder, and it allows us to see the change of a function over time, specifically as it approaches a value. Specifically as it approaches a value from one side or the other. It can approach from the left, it can approach from the right, and it tells us the behavior of the function as it approaches that value. This introduces a kind of continuity that really has never been seen before in math so far. And so this is really the idea that I would like to get started with in this course, this idea of introducing continuity and pictures versus videos, as it provides a great starting point for the rest of the material, and I feel like is just a great springboard into the rest of calculus. So I hope you've learned a lot today, and I can't wait to see you in the next lecture.